Hey everybody. I hope that you guys had a good day today. Sorry that I couldn't be there to help you guys out with that review, but hopefully you did okay. So I just wanted to um, take a chance to maybe try a few problems that you might see tomorrow on the quiz. You won't see these exact problems, but when we do our math party and stuff, I try to, reward you guys with some extra examples for your extra effort. So you definitely don't have to watch this video, but I have 4 problems that I think are going to be helpful for you guys tomorrow when you go take the quiz. Okay, so my advice would be pause this video, try the problems on your own, and then watch the solution. If you just watch it and you only watch what I do without trying it first, my opinion is it's really not even beneficial for you to watch this. Okay, so first one, -2 cosine of x equals negative sine of x times cosine of x. Okay, so what makes this a little bit tricky is, my first instinct when I see these equations is how do I, use a trig identity or something like that to make all the trig values look the same, right? That's our first instinct. But this one, there's no identities that are going to help. So the next thing I see is this term has a cosine and this term has a cosine. So maybe I can get these terms together and then factor out a cosine. Okay, remember, you don't want to divide both sides by cosine because then you're going to end up losing answers at the end. So I'm going to take this is negative sine times cosine. I'm going to add it to both sides. And now both of these terms have cosine in them. So I can factor out a cosine of x. And now I have 2 terms that multiply together equals 0. So I can set them both equal to 0. And now I can just solve these individually. So I'm looking for angles that have an x value of 0. So that happens at pi over 2 and 3 pi over 2. And then over here, I'd add 2 to both sides. So sine of x equals 2. And then I'm looking for angles that have a sine value of 2. That's not going to happen anywhere because remember, sine and cosine have to be less than or equal to 1. So the only solutions I have on this are pi over 2 and 3 pi over 2. Okay, so there's the first example. Nothing too tricky, but my guess is where you would, a couple, little traps here is you try to divide by cosine. If you do that, you're going to end up losing these answers down here. Those are going to disappear when you do that. And then my second thing that I bet you guys would try is you would try to use some identity, but we don't have any identities that take just a normal cosine and turn it into a sine. Remember, our identities are 1 minus cosine squared equals sine squared. Okay, so you can't use this with just 1 minus cosine equals sine. That's not an identity. Okay, all right, let's try another one here. So second one, cotangent squared equals cosine of x times cosecant of x. Okay, so again, the first thing I want to do when I look at this is see if there's any identities I can use to make all of the trig look the same. Okay, so first thing I see is the cosecant over here. So cosecant is 1 over sine of x. And if I have cosine times 1 over sine, that'd be cosine of x over sine of x, which is equal to cotangent of x. Okay, so once I do that, now I have all cotangents that I'm working with here, which makes solving this equation a little bit easier. Okay, again, don't divide both sides by cotangent or you're going to lose some answers. So instead, I'm going to subtract this cotangent of x onto the other side. And then I can factor out a cotangent. Okay, so I have cotangent of x equals 0 and cotangent of x equals 1. So I'm looking for angles that have a cotangent value of 0. That's going to be wherever tangent is undefined. So that's pi over 2 and 3 pi over 2. And then cotangent of x equals 1. That's first quadrant and third quadrant, so pi over 4 and 5 pi over 4. Okay, if you want the long way of doing this, that'd be 1 over tangent equals 1. So tangent of x equals 1. So same idea. We're looking for angles that have a tangent value of 1. Okay, so don't overthink this. I think a lot of people maybe are going to be overly antsy to use some of your trig identities. Maybe just try to take the easy route here. If you see cosecant or secant, start with that. Try to make your life easier before you start doing, 1 plus cotangent squared equals cosecant squared. Don't use that unless you see a bunch of squared terms and you have to use that one. Okay, 2 more to go. So the next one, let's try 2 cosine squared plus 3 sine of x minus 3 equals 0. Okay, so first thing you have to do when you see this problem is you have to identify that this is a quadratic that is going to need factored. Okay, how do we know that? Well, by looking at this, we have a squared term, we have a non-squared term, and we have a constant. Okay, so we're going to have to use our little sticky note problems and do some factoring here. Okay, however, if you look, we have cosines and we have sines. So we can't factor until we change one into the other. So the only way I have to do this is to take this cosine squared and to change it to 1 minus sine squared. Okay, so first thing is for the quiz tomorrow, do you know your trig identities? Okay, I'd say if you're going to study any, the ones that I would spend the most time studying are your Pythagorean identities. Cosine squared plus sine squared is 1. 1 minus sine squared equals cosine squared. I would really focus on that. Okay, so do you know your trig identities? Because if you don't know that cosine squared is 1 minus sine squared, then you're going to mess this up from the very first step. Okay, so step 1, we had to use our identity. Now I'm going to distribute. So 2 minus 2 sine squared plus 3 sine of x minus 3 equals 0. Okay, so now I can try to combine some like terms here. I have a positive 2 and a negative 3. So negative 2 sine squared plus 3 sine of x minus 1 equals 0. And now this is where my factoring is going to come into play. Okay, you guys can do this however you want to. It really helps me if I think about this as like just change those terms into y's and change this to negative 2y squared plus 3y minus 1 equals 0. Again, you don't have to do that, just how it helps me. So I need numbers that multiply to give me negative 1, but when I do all my distributing, it's going to be a positive 3. So it's going to be a minus 1 here and a plus 1 there. So I set both of these equal to 0. So I get y equals half and y equals 1. But they're not actually y's, they're actually sine of x's. So it's going to be sine of x equals a half and sine of x equals 1. So I'm looking for angles that have a y value of a half. So that's my pi over 6's, so first quadrant and second quadrant. So pi over 6 and 5 pi over 6. And then where does sine of x equal 1? That happens at pi over 2. Okay, so a lot going on there, but you would have had no chance if you didn't know your trig identity up at the top. So you got to make sure that you know your identities for a quiz tomorrow. Okay, last one. So secant squared minus secant of x plus 9 equals 11. Oops, positive 11. Okay, so first thing I see here is this smells like another quadratic, right? I have a squared term, I have a non-squared term, and I have a constant. So first thing I would do is get this set equal to 0. So secant of x, secant squared of x minus secant of x minus 2 equals 0. So I subtracted that 11. And now this is a quadratic. Okay, so you can factor this however you feel comfortable. So it's y minus 2, y plus 1. Set them both equal 0. So y equals 2 and y equals negative 1. But they're not actually y's, they're actually secants. So secant of X equals 2 and secant of X equals -1. Okay, so now I got to prove that I know what to do with secant and cosecant here. So secant is 1 over cosine of X. Take the reciprocal. So cosine of X equals 1/2. So when do I have X values that equal 1/2? So it happens at my pi over 3's, first quadrant, fourth quadrant. So 1 pi over 3 and 5 pi over 3. Okay. And then over here, 1 over cosine of X equals -1. So cosine of X equals -1 when I take the reciprocal. And that happens when my angle is pi. Okay. So those are 4 problems that I would know how to do for the quiz tomorrow. There's going to be a healthy mix of really easy questions and then more difficult questions, kind of like these 4 that I just showed you here. Okay. There are 12 questions on the quiz. So I don't think you'll have any time finishing unless you don't know exactly what's going on. Then you might struggle a little bit. But I think like the first 6 questions should be pretty straightforward if you've been doing the problems in class. And you know, I'm anticipating you having you know, probably needing 15 minutes for the front of the worksheet of the quiz, and then on the back, this last 6 questions are more challenging, so you might need maybe 20 to 30 minutes on the back. Okay, so time should not be an issue unless you just really haven't been preparing. So let me know if you have any questions. Again, if you're not feeling comfortable taking this quiz tomorrow, you need to email me before you go to take the quiz. Okay, I need to tell the sub who can take the quiz and who should not be taking the quiz and stuff like that. And we're not going to do you know, backtracking and say, well, I think maybe I shouldn't have taken the quiz. You know, I wasn't ready. If you're not ready, you got to tell me in advance. Okay. And then I'm happy to work with you, but we got to have that conversation. So please let me know if there's anything I can do for you guys. I hope that you have a good rest of your day, and I'll talk to you soon.